let's see. Did we, I think I have my two things confused. Did we read this trapeze problem? Did we got, oh, we did get it done, didn't we? Okay, so then we're going to be on number 23. Which, find the percent change to the nearest percent for the following function. So we're back in the exponential growth situation. But the one thing to notice about this one, again, in light of the homework quiz problem that we just did, is that the exponent is negative x. Okay? So if you simplify this, you can keep the 2 out in front. 1 minus 0.3 is 0.7 to the negative x power. They want you to pick which one. If you're going too quickly, you might accidentally pick, okay, maybe, because of what we just did. But even before that, if you see 1 minus 0.3, we're so used to 1 plus or minus the rate. So you might think that it's decreasing by 30%. But this negative in the exponent throws that off. So we want to raise 0.7 to the negative first power to see what that base really should be. 1.43, we'll round it. So this should really be 2 times 1.43 to the x power, and we find out that it's actually not decay at all. It's actually growth by what percentage? 43%. Good. 1 plus your rate. Questions on that? All right, number 24 gives us 3 functions, asking which has the largest average rate of change from -2 to 4 and which one has the smallest. These are really the 3 presentations of functions that you should be used to. A table, an actual equation, or a picture of the graph. So we're going to have to find the average rate of change 3 times and just do some comparing. So on a table from -2 to 4, an x of -2 is this point, an x of 4 is this point, and we just have to do the slope formula. So m equals y2 minus y1 will be -8 minus 0 over x2 minus x1, so 4 minus -2. That's -8 over 6, which reduces to -4/3. So that one's nice and simple because we have the x and y coordinates on both. If you're given the equation, you don't. So if I know that my x coordinate's -2, I have to find the appropriate y coordinate by plugging it in. So 2 times -2 is -4. -4 plus 3 is -1. The absolute value of -1 is 1. So 1 plus 7 leaves you at 8. So there's your first point. Plug in your 4, which is your ending x coordinate, and figure out its y coordinate. So 2 times 4 is 8. 8 plus 3 is 11. Absolute value of 11 is 11. 11 plus 7 is 18. So your slope formula there, 18 minus 8 over 4 minus -2, 10 over 6, which reduces to 5 over 3. Any questions so far? And when you're given a picture of the function, you actually kind of sort of already are given the points as well. So from -2, oh boy, that's tricky. What point would you say that is? -2 what? -12? I think that's probably the best guess. And all the way to 4, which is here, that's just 4, 0. So your slope formula here will be 0 minus negative 12, y minus y, over your x minus x, 4 minus negative 2, gives you 12 over 6, which is 2. So, which one's the biggest? G of x, h of x, or m of x, Connor? M of x, good. So, largest, m of x, so we're between 3 and 4. And which one is the smallest, Cameron? Because it's a negative number, very good. So g of x is the smallest, so your answer is 3. Okie doke. Okay. Let's jump to 37. Oh, good. You can do this one right on here because we have a chart to look at. And this is a 6-point question, so a lot goes into it. Temperature in Fahrenheit in a small town in New York, X months after January 1st. So if you look at your X-axis, that's already scaled for you. So this 10 would be 10 months after January 1st. That's October. 20 months after January 1st, which would be sometime in the next year, can be modeled by this function. Graph the function over the interval from 0 to 24. So the first 2 years is what we're looking at on the grid below. Okay, so you have to know from your flashcard information, you have to know what each of these values is going to do for you. Number one, this is a negative cosine curve. So the general shape is, where does this start? Does it start on the midline, at a maximum, or at a minimum? Minimum. Sine curves start on the midline. Cosine curves start at a maximum or a minimum depending on plus or minus. So because this is a negative cosine, it's going to start at a minimum. I think for graphing, starting with your midline is critical. So Evan, can you tell me where my midline should be? Where are you getting 12 from? Midline is like a vertical, a midline that's like going to be the middle of our curve from a vertical perspective. It's going to come right from your structure. Kaylee, can you help him? 50. D, that D is your midline. So we are going to put a dotted line at 50. And our graph is going to start at a minimum, which is going to be where? Do you know, Aiden? Very good. Because the amplitude is 40, we're starting 40 units below at 10. Which means we're also going to end at 10. But we have to figure out when our period, when our full cycle is supposed to complete itself, right? How do you calculate the period, Jay Kutch? Two pi over b, and what's b here? Good. 2 pi over 6. So that's a keep, change, flip situation. So that's 2 pi times 6 over pi. Our pi's cancel, and our period is 12. So this cycle that started at 10 from a y value perspective is also going to end at 10 degrees. This is temperature, yeah. It's going to end at 10 degrees on the 12th month, which we're going to have to sort of estimate on, yes? Because this is 15, so there's 12-ish. So I want my cycle to end there. And then everything is like evenly spaced between the start and the end. So if those are our minimums, our maximum is going to happen where? 6. 0 months, 12 months, halfway in between is 6 months. And at what y value will our maximum be, Grace? Nope. 50 is our middle temperature. Nope. So 50 is our middle. Look up at the board. And 40 is our amplitude. So our graph is going to oscillate back and forth, going 40 below to 40 above, 40 below to 40 above that midline of 50. So 90. Good. And then at what x value are we going to hit the midline? If this is 0 and our maximum's at 6, Kirsten? 3, good. So again, you're going to have to estimate there. And between 6 and 12, halfway between there would be at 9. So here is just one cycle. And I need to do one more because they said from 0 to 24. So again, this one's starting at 12, ending at 24. What's halfway between 12 and 24? 18. So at 18, we're going to reach our maximum. So really every 3 units, we have a critical point. Which makes sense, right? Everything is split into intervals of 4. If your period was 12 months long, split it into fourths, and you get a 3-month interval. So 12, 15 should hit, then 18 we're at a maximum, then at 21 we're going to hit our midline again, and we're going to go down to our minimum. So there is a sketch. Okay? It said to identify the period. We already did that. Period is 12. Midline, oh God, sorry, I just saw more. Period, midline, amplitude, and label these values on the graph. So, 12, there I've labeled my period. And explain what each means in the context of the function. So in the context, there is an explanation that we did a problem like that the other day where it was in the context. So, Jordan, give it a whirl. What does the period equaling 12 mean in the context of the problem? Say that one more time. Every year what? How do we feel about that? Nathan wants to help correct it a little bit. Go ahead, Nathan. The cycle of what? Correct. So there, just add that in there for the context of the problem and you're good. So every 12 months. And Jordan, you switched it to 1 year, which is okay, but you might want to keep it 12 months just so they know that you're taking the period. And I mean, we would know what you were doing, but every 12 months the temperature cycle repeats itself. There's your period. The midline, we already said, was 50. What does that mean in the context of the problem, Nate? Yeah, I think average is a nice way of putting it. It might not be the exact average temperature, but you also could say something along the lines of the temperature fluctuates above and below that 50 degrees. Nathan? If you actually listed out the temperatures, though, I don't know if the middle number would actually be 50 either. I think, honestly and truthfully, I think that we would accept any of those because it all shows that you understand the context. I'm just going to say, just to stay away from the technicality of average temperature versus median temperature, I'm just going to say that the temperature oscillates above and below 50 degrees, equally above and below 50 degrees. Oscillates equally above and below 50 degrees. And the amplitude, this might get some people. Haley Smith, what would you say the amplitude is? How'd you get that? The high point, which was where? 40, correct. 40. Not negative 40. Yes? The A value is negative 40, but the amplitude is always a positive number, so make sure you say that. And as far as explaining again in the context of the problem, you can say the temperature goes 40 degrees above, 40 degrees above the middle and 40 degrees below. Go ahead. No, because the difference in temperature from the high to low is actually 80, right? From the middle, yeah, yeah. So your homework tonight are these blue questions, 11 through 20, 29 to 32, and 35 to 36 from skill test number 1. And then again, a similar